Okay, so just to reiterate, I'm Vera Mays from the Learning Commons, and I'm a math instructor here at TCC. So my intention today is to go through the review. It's got about, I think, 23 questions or so on it, which is usually about the same length as your tests are. If you have questions as we go through, please feel free to ask. If you want me to create another one that's similar, please feel free to ask that also. So any questions before we get going?
No, thank you.
All right. I'm going to bring up the dreaded PowerPoint, but hopefully it'll be beneficial this time. All right, so can everybody see my slide?
Yes.
Okay. And I'm going to be asking for input as we go through, so feel free. If you know something, let me know. If you have questions on something, let me know that also. All right, so let me get a pen and we will get going. All right, so state the domain. So if we're talking domain, are we talking the X value or the Y values? What do you guys think?
The X?
Yes. Keep in mind, X comes before Y in the alphabet and D comes before R in the alphabet. So domain goes with X, range goes with the Ys. So I'm not trying to find anything about f of X out. I'm trying to find out what X's are legal for me to use. And the one thing we've learned about fractions, until you get to calculus, we cannot divide by 0, can we? It's a no-no. So when we look at this, we're trying to find out what number would make the bottom go to 0. So we just set it equals 0, and then we'll know who the bad guy is and who we want to avoid. So all we have to do is solve for X. So bring the 27 over. We get negative 3X equals negative 27. Divide by negative 3. So that gives us X equals 9. So that's not saying that X can be 9. Keep in mind, this is the thing that put the bottom equal to 0. So X cannot be 9. So there's a couple ways to write this depending on, and they did it in Set Builder. So we can see A is the choice in Set Builder, but they won't always give it to you in Set Builder. So I wanted to look at it also in interval notation very quickly. So we're saying X cannot be 9. X can everybody to the left of 9, everybody to the right of 9. So if I had to write this in interval notation, I like to remind myself about the infinities, who lives on which end. So this could go from negative infinity up to 9, stop, jump over that 9, because he's bad, he makes the bottom go to 0, start on the other side back at 9 and go all the way up to positive infinity. So depending on which way they ask you to give the answer, you could just simply be able to say X can't be 9. Or if they ask for an interval notation, then you're going to want to tell them all the numbers you can use and make sure you stop at 9 and jump over it. Okay, any questions on that one?
No.
Okay, so as a fraction, we're not allowed to divide by 0. So we just set it equals 0 to find out who we need to avoid. All right. Unfortunately, it's going to make me clean my drawings each time. All right, so this one is a solve. Now, when I solve these, one of the first things we always remind ourselves is, again, what numbers are in our domain? Which ones can we not use? So we look at the bottoms. We set the bottoms equal to 0 like we just did. We said, okay, we can't use 2 because 2 would make this fraction go to 0. 3x plus 1, set that equals 0 and solve it all the way for the x. So x cannot be a negative 1/3. So just keeping that in mind off to the side till we get done. And then we just need to make sure after we solve it that none of our answers match these two, and then they'll be good. All right, so any suggestions on how to solve this type of problem? Anybody have a good strategy?
Maybe factor out?
Not yet. Anytime you guys see a fraction equal to a fraction, you're going to want to use that cross multiply strategy. So let me get a bar. So you're going to want to multiply these two, and you're going to want to multiply this way. And you're going to set the green bar equal to the red bar. So we've got 5 times 3x plus 1 equals 3 times x minus 2. It's kind of a shortcut way of getting around getting a common denominator. And now I don't have fractions to deal with anymore. And so now I can just go ahead and distribute on both sides and see what I have to deal with. So on this side, if I distribute the 5, I get 15x plus 5. On the right-hand side, if I distribute that 3x minus 6. Now I'm solving, so that means I want to get my x's on one side and my constants or my numbers on the other. So I'm going to bring this 3x over to the left since 15 is larger. And I'm going to bring this 5 over since it doesn't have an x. It can't stay on the left. So let's see what's left when we move those around. This guy canceled. This guy canceled. So I'm left with 12x equals negative 11 when I combine these two numbers. And then I divide by 12. So I get x equals negative 11 over 12. Now that was not one of the values I said I couldn't use. So that's a good answer. And here we are at B. All right, any questions on this one?
No.
Okay. I think you're the spokesperson today, it sounds like. All right, let's look at the next one then. All right, so this one says solve for x. Now, first thing I notice, I see an x on both sides. So I know I need to get them on the same side, just like the problem we just had. So that's kind of tiny. I'm going to rewrite that. So I'm going to add sx to both sides. So it cancels over here. I'm left with tx plus sx equals p. Now, what am I solving for? Oh yeah, x. So I'm trying to isolate the x. And the only way I know to isolate these, because I don't know what t is and I don't know what s is. If it were a 3x and a 5x, I could just add those numbers, but I don't know what they were. So the only way I know to isolate this is to factor it out. And then I can divide it since it's multiplying now. So I have to divide both sides so I keep everything balanced. I can see it cancels over here. So I'm left with x equals p over t plus s. If there had only been one x, I just would have divided by the t and it would be done. But because it showed up on both sides, I have to get them both on the same side so I can work with them together. This is probably one of the trickier ones for students. They get to here and then they're like, what do I do? What do I do? It's this factoring step that most students forget to do. That's the only way we know to separate the x from the t and the s is to factor it. All right, any questions on this one? If you guys could give me like a thumbs up or something, let me know you're good. That will help. All right, well, let's go to the next one then. Okay, so this one says write the expression in lowest terms. So simplify, reduce, those are all words that should kind of pop into your head anytime you see a fraction, right? So I would love to just be able to cancel the x squared with the top and the x squared in the bottom, but I can't do that. I can't cancel anything until I break these guys apart into groups. So I need to see what the factors are that are inside of these. Now, I don't know how good you guys are with factoring or how your teacher's done it. There's so many ways to factor. If you get stuck, one suggestion is kind of look at some of the factors they have over in the answer key. So, you know, on the bottom, let's see, how do I want to do this? When you guys see something like this, what strategy do you think of to factor?
I would use 2 times 7, which is 14, and then break it apart. So
Okay. So you're using the AC method. Okay.
yeah.
So 1 and 14,
Uh-huh.
2 and 7. Are you breaking it into groups then, or are you just going straight to parentheses?
So I would, after that, I would do 2x, 2 square, 2x square, minus 2, and then,
Okay,
yeah.
good. You're going to do grouping. That's what I was thinking too. Okay, so we need a negative 9x, and the only factors of 14 they'll give us a 9 are this 2 and the 7. Because it's a positive 14 that we're dealing with, we know they're either both plus or both minus. The middle term says they both have to be minus. So we're taking this negative 9x apart and we're making it a negative 2x and a negative 7x. And then since we have 4 terms, we know anytime we have 4 terms, we can use grouping. So we're going to group the first 2 together, and then we're going to group the second 2 together. So when I look at the first 2, I ask myself, what do they have in common? Well, I see they both have a 2 and they both have an x. So I'm going to divide that out of both of them. So let's see what's left. 2 divided by 2 just leaves me with a 1. There were 2 x's. I pulled 1 to the front, so that leaves me with 1. Minus 2x divided by 2x leaves me with a 1. I bring the next sign straight down, and then I say, well, what do you guys have in common? And it looks like they both have a 7. Should that have been, oh, I missed one sign, I'm sorry. This was a minus. Negative 2x, negative 7x gives me the negative 9x. So really what I'm doing is dividing both of these by a negative 7. So negative 7 divided by negative 7 gives me a positive 1. The x stays behind. Positive 7 divided by negative 7 gives me a negative 1. Now, if I've done this right with grouping, you'll always see a new term emerge that matches on both the first group and the second group. So you can pull that to the front. And when you factor it out of the first group, it cancels, you're left with a 2x. When you factor it out of the second group, you're left with a minus 7. So this is the top. We're done factoring the top. Now let's look at the bottom. So we've got 5x squared minus 8x plus 3. Using the AC method, we're going to take the 5 times the 3. It gives us a 15. Sorry, 1 and 15, and 3 and 5 are the only choices for this. So we look back over here to our middle term. We needed to get an 8. Well, these two are the only ones that can give us an 8. The 15 is positive, so I know because the middle term is negative, these both have to be negative. So I'm breaking the middle term apart into 2 pieces, a negative 3x and a negative 5x. If I combine those back together, I still have the negative 8x that I started with. And now I'm going to group again. So I'm going to group this one and then this one. So when I look at the first 2, I see, well, they have an x in common. That's about it. So if I take an x out of both of them, I'm left with 5x minus 3. Bring the next sign straight down. 5 and 3 really don't have much in common besides 1. So a negative 5x divided by negative 1 makes it a positive 5x, which is good because it now matches. A positive 3 divided by negative 1 makes this a negative 3. And now I'm seeing that factor that matches, so I can bring it to the front. And let's look to see what's left behind. So when I take this first group and I pull the 5x minus 3 out, I'm left with an x. The second group, when I take the 5x minus 3 to the front, I'm left with an x minus 1. All right, we have everything factored. Here's our bottom. It took us a minute to get here, but let's see what we have. So on top, we have x minus 1. Hang on. X minus 1, 2x minus 7. On bottom, we had 5x minus 3 and an x minus 1. And leaks, there's at least one group that cancels to give us our final answer. So it looks like it's B. So you need to factor the top and you need to factor the bottom. All right, I want to take a second. Any questions on this one? This one took a lot of factoring. And I would have to say factoring is one of the most important things you guys can take away from this class. When you go to, if you're going to college algebra, you need to be able to do this. So you need to spend as much time as you can and get as comfortable as you can with this. Okay, any questions on this one?
I do have one question.
Okay.
How did you know when you were getting on there and getting started to work the problem that you should use the AC method? Sometimes it takes me a bit to figure out my strategy.
Sure. When I see that the first coefficient is not a 1 or the last one is not a 1, if I have a trinomial, so three terms, right?
Mhm.
If the first one is a 1x squared, I immediately will go to trial and error because there's only one choice for this one. And let's say that it was still a 7, then we know there's factors of 7 are only 1 and 7. So the choices are a lot more limited. If you have something where the first coefficient is not a 1, I jumped the AC method.
Oh, okay, that makes a lot more sense. Makes it a little easier.
And we'll have some more you can see as I go through. I'll try to talk through my strategy of why we chose that one.
All right, oh, that's very helpful. Thank you.
You're welcome. All right, well, let's look at our next problem. Okay, so this one says factor completely. So we know when we're factoring, first thing we always look for is a GCF, right? Well, 4x squared plus 25, no. Then we look to see, is it 4 terms? So we can use grouping. No. Is it a difference of 2 squares? Is it like x squared minus y squared? Nope. Okay, is it x squared plus y squared? That's what this one looks like, doesn't it? This one is always prime. It's one of the few combinations, unless there's a GCF, we can't factor the sum of 2 squared terms like this. So this one is prime. And if you weren't sure and you wanted to try to plop it into the quadratic formula just to see what there were solutions, it would give you imaginary answers. Okay, any questions on this one then? That was a short one after that last one. All right, welcome, Mia. All right, let's look at the next one then. So this one, they gave us a function. Let me go back to blue. They gave us a function, which we know is the same thing as y, right? That's our buddy y. And they said, find the value of this function when x, whatever's in the parentheses, remember this started out as, let me erase this, started out with x in the parentheses. So that means they're telling us x is -7. So that means that we just have to, everywhere we see an x, plug in a -7. And then we're going to simplify. So what do we get on top? 3 times -7 gives us a -21. -7 squared gives me 49 minus 49. So I end up with -21 over 0. So I'll give you two choices. These two are not the answer. So it's either 0 or it's undefined. What do we get if we have the 0 on the bottom of the fraction?
0.
Try putting it in your calculators and see if it gives you a 0 or if it gives you an error. If you can't remember, that's the best way to put it in. You put in -21 over 0, your calculator is going to tell you error. You cannot take a number and divide it by 0 until you get to calculus. When you get to calculus, they'll tell you a method to keep going. So for now, we're just going to say this is undefined. It's the one number, one of the two numbers that were not in our domain, because it would make the bottom go to 0, like we talked about for one of the first problems. So like I said, if you're not sure, just put this in your calculator, put it into decimals, put it into whatever calculator you're using, and it will tell you this is not something that gives us a nice answer. All right, any questions on this one? All right, let's keep going then. Please ask if you're not sure. I know this stuff. We're here to see what questions you guys have, so keep that in mind. I don't have to take the test. I have to give it, but I don't have to take it. So this one, it says now evaluate when x is -1. So we're wanting to find the value of this function when x is equal to -1. So this one's a little bit tricky because of the exponents. And that's why we put it in here, to see if you're good about following your order of operations. So when I look at this first term, I see a multiply by the -3, but I see an exponent of 3. So which do I do first? Do I multiply by 3 or do I take it to the third power?
Take it to the third power.
Excellent, Mia, good job. So we're going to take -3. So -1 to the third is -1 times -1 times -1. So that's an odd number of negatives. So it's still going to stay negative. 1 times 1 times 1, still negative. Okay, so here again is the same thing. So I'm going to take Mia's advice again. I'm going to take -1 times -1, which is a positive. These guys don't have exponents, so I can go ahead and do the multiplication. Negative times negative gives me a positive, and then bring down the 9. All right, so now let's try to do a little bit more cleanup because I still have some parentheses. So -3 times -1 gives me a positive. 4 times 1 gives me a 4. Bring down the 11 and the 9. So at this point, I can already eliminate the negative answer. I can see that these are all positive. So I want to go through, I like to group if I'm not using my calculator. So 20, and so that's, so here's our solution. This is the tricky part, knowing, do I do the exponent first or the multiplication first? And you guys have probably all talked about PEMDAS, right? So that exponent comes before any multiplication or division. All right, any questions on this one? This type's always on the test and people miss it because of those silly exponents. You could type it straight in your calculator. Once you see how I wrote it up here with the parentheses, at this point, I could have stopped and typed this expression straight into my calculator, just like that. Even if you just have a basic scientific calculator, it has parentheses built in usually, and you could just type it straight in. All right, any questions? Everybody okay? Okay, I see at least, okay, I got 2 thumbs up, so I guess we'll go on. All right, so this one again is a solve. I can't hardly read this font. P equals RS over T. What are we solving for? Oh, R. So we're trying to get the R by itself. So that means this S and this T have to go away. I can do it 2 different ways. There's one way I like to do better, I think, because I can do it step by step. So to get rid of the one on the bottom, since it's division, if I multiply both sides by a T, it will cancel. And then I have T times P equals RS. S is multiplied by my R, so now I can divide both sides by S. I can see it cancels. And then my final answer is TP over S equals our R. So they put PT. The order doesn't matter because we know that 3 times 2 is the same thing as 2 times 3. So when you're multiplying, this is commutative. So if you get T times P, look for one that has T times P. their order might be PT, same answer. All right, any questions on this one? It's always, always, always important to identify what are you trying to get by itself. This guy wants everybody else to go to the other side. What is the S doing? It's multiplying. The T is dividing. So what did we do to get rid of the division? We multiplied. To get rid of the multiplication, we divided. There was no addition or subtraction, so this one was fairly nice. And we ask you to do these kinds of equations because when you get into a science class or you get to, say, a business class or accounting class, you're going to see formulas like this that you're going to have to work with and manipulate. So we want you to have some practice doing it already and be a little bit more comfortable. Okay, any questions?
Yes, could you show one that's a little bit longer that has addition, subtraction, and parentheses in it? I've had a hard time factoring those.
We'll get to one like that.
Okay, thank you.
But most of the time when you have literal equations, there's not much to them. They're fairly straightforward.
Gotcha. Okay.
Hopefully by the time we get done, we'll be able to see a little bit of everything that you would see on the test. Okay, LCD. I'm old school, so I call this common denominator. Or some people call it LCM. So we're just trying to find basically, before we actually do the addition or subtraction, we need to find a common denominator. So it's kind of hard. They don't look at all alike, do they? I look at this and I say, you guys have nothing in common. And they laugh at me. They're like, if you factored us, you could see what we have in common. So I'm going to look at the first one. I'm going to ask myself, I know I always look for a GCF first. Well, it looks like 3 goes into both of them. If I divide both of them by 3, I get x plus 4. Okay, I can see the pieces now. And the second fraction says I'm hiding some secrets too. You need to factor me. So I see that they both have a 5 in common. Okay, if I factor 5 out of the first term, I'm left with an x. If I factor 5 out of 20, I'm left with a 4. Boy, I was fooled. They do have something in common. So the least common multiple, or LCD, whatever you want to call it, the first fraction needs there to be a 3 and an x plus 4. Second fraction says, well, you already got my x plus 4. That's great, but I need you to add a 5 in there. So you can see that our final common denominator, if I were adding or subtracting these, would need to be 15 times x plus 4. They hide secrets inside that you won't find until you factor them. All right, any questions on this one?
What about the 7 and the 17? Would you not factor it because it doesn't have any x's, or do you just?
Well, because they're not asking us to actually add or subtract it, so we can ignore the bottoms. They just wanted to know what common denominator would you use if this were in a problem. So very good question though. If I put a plus between it and I was supposed to find an answer, then I would, next step, I would have to work with a common denominator, and we'll have one like that. So one where we have to build a common denominator and get everybody to agree. But this one, they just said, predicting ahead, what would you use if you were trying to work with these two fractions? All right, let's look at the next one then. Okay, now we need a common denominator because we're adding or subtracting. So they've really been nice to us on this one. There's only one trick. This subtraction is really tricky when you're doing it. So what I always tell my students, let's write this first fraction because we're not going to change it to begin with. I want to take this negative, I want to change it to a plus and float that negative to the top of the fraction that it comes right before. Adding a negative number is the same thing as subtracting a number, right? So I haven't changed the problem at all. This will just make it easier for you as you go through. Now, this is kind of a funny one because they gave us a common denominator. So I don't have to do too much yet. I may have to factor it to finish up my canceling, but the bottoms match. So I keep the bottoms and I just bring both sets of tops over. So here's the first one, plus negative times 2b plus 3. So I do need to go ahead and get rid of these parentheses that I had to create, distribute. So I get 3b minus 2. A negative times a 2b gives me a negative 2b. A negative times a 3 gives me a negative 3. So b squared minus 25. So if I add up like terms on the top, I see I have a 3b and a negative 2b. So that gives me just a 1b. And then if I add up the numbers, I have a negative 2 and a negative 3. So that gives me a minus 5 on top, b squared minus 25 on bottom. All right, it's a fraction. Whatever form we have of fractions, we know we need to try to cancel. I can't cancel with this bottom because it's hiding its secrets until I factor it. So let's factor the bottom. B squared minus 25. Well, that's two terms with a minus between them, and they're both square terms. So I know this is that difference of two squares where one is minus, one is plus, and then they match. So b squared is a b and a b. Square root of 25 is a 5 and a 5. So now I can start to see what is the same from top to bottom. And I see this group matches this group. So this group goes into itself one time, and it goes into itself on the top one time. So what's left? So there's only a 1 on top. 1 times b plus 5 just gives me a b plus 5. So here we go. So they already gave us a common denominator. The only tricky part was dealing with that minus, and I always move it up and distribute it to the second fraction. It makes it so much easier to do it first than after you've already gotten a common denominator and you're working through it. A lot of students miss it and they'd rewrite it as a plus if you don't deal with it first. All right, questions? How are we doing? We're on question 10, so we're almost halfway through. Any questions? You guys feeling good? You're going to see lots of factoring on this test. It's funny because my college algebra students are also doing lots of factoring on this test that they have. All right, we're going to go on then. All right, the next one says write the expression in lowest terms. There's something about that one. It just kind of looks almost the same, doesn't it? 10 minus x, x minus 10. So you guys talked about in class probably, anytime it's the same, except the signs are exactly different. If I factor in -1 out of the top, -1 from a positive 10 gives me a -10. A negative x divided by -1 gives me a positive x. And if I rewrite that -1 and just switch the order, that's x minus 10. Put it on bottom, put it over the bottom, and I can see I have something that cancels. And all I'm left with is the -1. So anytime you see something that's the same, except for like here, the 10's positive, here it's negative, the x is negative, and then it's positive. Let's say 3 minus x over x minus 3, 2 minus x over x minus 2. All of these reduce and just leave you with a -1. So it's kind of a tricky one. There's not a lot of work, but you got to recognize it. You got to say, wait, you guys are really similar, except for you change signs on me. So how are we, was that okay on that one? It's there. It's always there. So, okay. All right, so this one says, write the final answer in lowest terms. So we know they want us to reduce at the end. Okay. So I'm going to write this 5x plus 3. Okay. Oh, there's that minus. I'm going to go ahead and slide that minus up with the 2. Okay, so I need a common denominator because I'm adding. If I were multiplying or dividing, I wouldn't need one necessarily. But if I'm adding or subtracting, I need a common denominator. So I need this one to spill its secrets. I need to see what's inside of there. So let's break that down. X squared goes to X and X. Again, it's two terms with a minus. So I know it's a difference of two squares. Square root of 9 is a 3 and a 3. All right, so now I need to build my least common multiple, my LCM, my common denominator, whatever you've learned to call it. The first fraction says I need these two pieces. All right. Second fraction said, do you have my X plus 3? I'm like, yep. And they're like, you got me, you're good. So now if I want to add these guys together, their bottoms need to match. So this one has the X minus 3, but it's missing the X. I'm sorry, it has the plus 3, it's missing the X minus 3. And I got to make sure my fraction stays balanced. So I got to multiply top and bottom by what it's missing. So let's see what we have. The first one didn't have to change because it already had everything that was in the common denominator. This one has, and go ahead and distribute that -2. So -2x plus 6. And actually, I can go ahead and put these all over one fraction since they all have a common denominator now. Little wonky fraction bar, but all right. So 5x minus 2x gives me a 3x. So those are done. 3 plus 6 is a 9. All right, I would love to do some canceling. My students will tell you, I love to cancel. Love, love, love it. But I can't cancel anything yet. But I'm looking at this top one, I'm thinking, I think I can factor you. Then maybe you'll spill some secrets and I can cancel something. So they both have a common term of 3. So if I take a 3 out, 3x divided by the 3 I took out leaves me with an x. 9 divided by the 3 I took out leaves me with a 3. Ooh, I'm happy, happy, happy. Look at that. There's some things to cancel. And so I'm left with 3 over x minus 3. So don't try to build a common denominator until you factor all the bottoms and find out what's really, really included.
I have a question.
Mm-hmm.
Why did you change the minus to addition?
Well, our brains seem to process addition easier, right? So if you say add a -2, or if I say subtract 2, it has the same effect. Like if you have an account and I'm saying add a negative to it, it's the same as me telling you to subtract 2. But I've just found over the years, our brains process addition a lot easier. So I can take the, it was originally a +2 on top. I can switch those two and it has the same effect, but it's so much easier to use as you go through the problem.
Okay, so it wouldn't be +3 minus +6. It would just automatically be 3 plus 6.
Well, it's a +3 and it's a +6, so they're both positive. So they gave me a +9. Is that what you were talking about there?
Yeah.
Okay.
I didn't know if we could have done that, like change it to plus, because I would have done +3 minus +6, and I would have gotten a different answer.
Yeah, see, if I distribute this negative, and that's why I try to do it, because otherwise, if you had just multiplied, let's say you left the fraction as is, and you have a minus, let me move that down a little bit. You have a minus in front of the fraction, and you're multiplying top and bottom by x minus 3. So minus would still be in front. You would distribute on top of the fraction, you have a 2x minus 6, and then you'd have that common denominator. What happens with most people is they distribute the negative to the 2, but they forget to distribute it to the -6. So I like to deal with it first because I've done this for so many years. I know where you guys are likely to forget and make a mistake. And that's why I just tell my students to do it first, and then it will be there to be part of the problem, and you won't have to decide later which one gets that negative. You don't have to do it this way. I've just found much higher success levels with having people do this.
Yeah, I really find it easier, so I would use this one. Thank
Okay,
you.
you're welcome. Okay, any other questions or comments here? All right, let's go to the next. Ooh, this one's got lots of factoring. Nice. Okay. I don't know if you guys remember this little saying. When you have a something divided by something, we don't really have a lot of rules for division. So we want to change it to a multiply. So a few years back, I heard this saying, keep, change, flip. Have you guys heard that? Did anybody, any of your teachers teach you that before? Lauren, yeah. Okay, okay. All right, so what it says is, before you do anything, keep the first fraction. Don't wait to do it at the end because you will forget. Keep the first fraction, change the division to a multiply, flip the second fraction. Now I don't have to worry about the fact it was originally division. Now it's a multiply, so I know as soon as I get everything factored, I can cancel, cancel, cancel. So this is a good one. It's got a lot of different factoring type of things going on. I think it was Lauren asked earlier, why did I use the AC method versus just, like trial and error? You see here, the first coefficient is a 1. I am just going to go straight to trial and error because the only way I can get a y squared is a y and a y. So it's pretty limited. Factors of 10, 1 and 10, 2 and 5. The only one that will give me a difference of 3 is that 2 and that 5. So because it's a -10, I know one of them's positive, one's negative. That's the only way to multiply and get a negative. The larger number needs to be negative, being dictated by the middle term. So the 5 is a negative, 2 is the positive. And to be honest, guys, it doesn't matter what order you factor these in, as long as you get them all factored. Like you may say, oh, look, this one's not too hard. Let's do that one next. They both have a 4 in common. So I factor the 4 out. I'm left with y minus 5. I'm kind of getting excited. Look, I already see something that cancels. Let's try the bottom of the first one. They both don't have a 3, so I can't pull out a 3, but they both have some y's, a whole bunch of y's that agree. It looks like they at least both have 3 of them. So that leaves 3y minus, so this is the tricky one. Keep in mind, you're taking each of these and you're dividing by what you pull to the front. If you have 2 pieces, when you factor something out, you should still have 2 pieces in this parenthesis. So y cubed divided by y cubed leaves me with a -1 there. One last one, and then we can see what kind of reducing we can get into. All right, so I only see that these guys have a y in common. I'm going to write it over here, so in case I've finished, 9y squared minus 1. And so now I see, oh, that's a difference of 2 squares. So 3y, factors of 1 are 1 and 1, 1 minus, 1 plus. So I usually go off, you can see I kind of go off to the side and do my scribbling. Here's where everything gets brought together. I always use pink for canceling. I like to cancel. Okay, and remember, as long as it's on the top of either one, it could cancel with anything that's on the bottom also. So first thing that jumped out at me was this y minus 5. You guys see anything else that cancels?
3y minus 1.
Okay. Anything else? Now here's a tip. If you don't see it, rewrite it. Just do a little bit of cleanup, leave everything off. You don't need parentheses on that one, I guess. Leave everything off that you've canceled. And let's see what's left. Okay, now do you guys see anything else that cancels?
The y.
Yeah. Oh, and I left the 3y plus 1 off. Oop. Bring it down. I forgot about it. Yeah, this y will cancel. There were 3 of them on the bottom, 1 on the top. So now this is a 2. So now I can go over here and find something that has a y squared. And there's my answer. So you had 4 terms that all needed to be factored, and they had a bunch of stuff that was in common, because this really cleaned up nicely from our original fractions. Okay, take a second, see if there's anything here that you have questions on. Anything? All right, let's go to the next one then. We can always come back if something strikes you at the end and we can look at something again. All right, so solve it, write it in lowest terms. Well, I don't see anything I can factor on top, so I'm going to leave it alone for a second. The bottom, I think they have a common term of 3. Oh, this is tricky. Look at that. There's another one of those 7 minus x, x minus 7. So when they reduce, what do they leave behind? Guys, remember we just did like 3 of these.
-1.
Yeah, so this ends me with a -1 over 3. Who knew that this would look this pretty when it got done? Now be careful that you don't just say it was -3. This 3 needs to make sure it ends up on bottom, since it was on bottom of that fraction. Very good. So sometimes they'll give it to you straight like the other one we looked at. Sometimes they'll embed it in another one where you, once you have to factor, you'll see that pattern emerge, and then you can say, oh, you cancel, you leave behind a -1. That was kind of nice after that long one we had. All right. All right, let me put 2 on the same page here. All right, write the expression in lowest terms. So that I see a fraction, so to me that means I need to simplify, right? Simplify or reduce might be other words I would think. I can't factor the top, so I leave it alone. Looking at the bottom, I see 2 terms with the minus. They don't have anything in common, but the first one is a perfect square. The second one's a perfect square. So I can go ahead and factor this into the difference of 2 squares. So I know x squared is an x and an x. 16 square root of 16 is a 4 and a 4. 1 minus, 1 plus. Square root of 25 is a 5. And now I look at this and I say, woohoo, 4x plus 5 goes into this one time, and it goes into this one time. So all I have left on top is a 1 and a 4x minus 5 on the bottom. That wasn't too bad at all. No wonder they didn't give me too much space to do it. Okay, any questions on that one? You can tell we like the difference of 2 squares. We like the fact that it has a nice pattern, that it's a nice, fairly straightforward to factor it. And it works even with larger exponents. So when I look at this, as long as it's an even number, I can apply that difference of 2 squares. If I see 2 terms, they're both squares, I can just go ahead and start breaking it up into a difference of 2 squares. So what do you guys think I could do that would be the same term that would multiply together to give me y to the 4th? What could I use?
Y to the second.
Yeah, because when we multiply, we add exponents. So when I multiply that first times that first, 2 plus 2 is going to give me the 4. Factors of 1, well, we're kind of limited there. It's a difference of 2 squares, so one's a minus, one's a plus. Now this one, we talked about a little earlier, it's the sum of 2 squares, so it will never factor again. So it is going to be part of my final answer. So at this point, if I was you, I would come down and start putting it in your answer blank. Now this one is a minus. So it's another difference of 2 squares that was embedded in a difference of 2 squares. So this one factors again. Y squared comes from a y and a y. Factors of 1 are 1 and 1, 1 minus, 1 plus. So don't stop too soon. This one still has the minus, so it potentially can keep going. It needs to be an even number for this to work. Right. Any questions on these two problems?
So, the other one you didn't factor it because it was positive? or
Yes, yes. Think about, it's a positive 1, right? So if you think, well, maybe that's y plus 1 times y plus 1, that'll give me a y squared, it'll give me the 1, and it's all positive. But when I FOIL this together, I get y squared plus 2y plus 1. Well, that didn't work, right? If I make it y plus 1 and y minus 1, that ends up, if I FOIL it, to y squared minus 1. So there's no combo that will give me the sum of 2 squares. So as soon as you see that, you know this part is done. So good question. Very good question. It's amazing the difference a minus or a plus can make, whether you can keep going or whether you just say, you're done, stop, bring me to the final answer. All right, any other questions on this one or these two? All right. Okay, we're doing some more factoring. Now the first one, I see 4 terms. So anytime I see 4 terms, I know we're doing grouping. Now this one I look at and I see the first coefficient's not a 1, the second one's not a 1. So I use the AC method. Some people use a box method, some people use a cross method. There's so many ways to do this. So if the AC method doesn't work for you all the way, come work with one of us, come work with a tutor or something, and we'll look at the different ways and we'll find something that makes sense to your brain in particular. All right, 4 terms. I'm going to group the first 2, and then I'm going to group the second 2. So when I look at the first 2, I ask myself, see, I'm ignoring the purple ones for now, only the red. So what do these guys have in common? Well, they both have a 2, okay, and they have some x's. So I'm going to pull some x squareds out of both of these. So if I take the 2 out of the 2, that leaves me with a 1. There were 3 x's, I took 2 of them. That leaves me with a 1x. Bring down my sign. 8 divided by 2 leaves me with a 4. There were 2 x's, I took them to the front. So that guy's done. Bring the next sign straight down. What do these guys have in common? Well, 5 goes into both of them. So negative 5x divided by 5 leaves me with an x. I'm hoping it matches this guy, right? That's the magic thing that happens with grouping. 20 divided by negative 5 leaves me with a negative 4. And now I kind of call it my magic factors. They match. So I have a new common term to pull to the front. If I pull it out of the first group, I'm left with a 2x squared. When I pull it out of the second group, I'm left with a negative 5. Now this is not a perfect square and this is not a perfect square. So this one, until you use quadratic formula, you're done at this point. That's all we can do with this. So 4 terms, I'm always going to use grouping. So any questions on number 17? Most of my students like grouping because they're only doing 2 things at a time. And then they can tell if they did it right because this matching factor will pop up. All right, so this one we talked about, we need to use the AC method. So we know every quadratic is ax squared plus bx plus c. So this is where the AC method gets its name. We're taking the a times the c, so we get negative 15. We're going to build a table, and then we're going to kind of split this middle term apart into 2 pieces, and then it'll look like grouping, and I can use the grouping method. So factors of a negative 15. Well, -1 and a positive 15, or a positive 1 and a negative 15, 3 and -5, or -3 and 5. And I think that's all the factors of 15. So I'm going to go, I used my A and C, and now I need to find one that combines to give me the B. So I want something that will combine to give me a positive 14. Do you guys see it?
-1 plus positive 15.
Yep. So I'm going to take this 14x and I'm going to break it into pieces. I'm going to bring the 5x squared down. I'm going to bring the -3 down. 14x though is going to get broken down into a -1x and a positive 15x. Still positive 14 if I add them back together. So I haven't changed the problem in any way. But now I have 4 terms. So now I can use grouping like I did on the one right above it. So I look only at the first 2 terms. I ask myself, what do you guys have in common? Well, a 5 and a 1 doesn't have any common, but they both have x's. So I can factor an x to the front. If I take 1 x out of each term, that leaves me with a 5x. 1x divided by x leaves me with a -1. Bring the next sign straight down. What does 15 and 3 have in common? Well, 3. So 15x divided by 3 gives me a 5x. That's looking good because it matches the first group. 3, so -3 divided by 3 leaves me with a -1. Makes me very happy because I can see that matching group. So I bring it to the front. And let's see what's left. If I take it out of this group, I'm left with an x. When I take it out of this one, I'm left with an x plus 3. And I have that booger factored. Now on the test, if I had time, I would go back and FOIL this back together just to make sure I really get what I started with. Now, if some of you have been using a box, let's see if I can create the box. Same table. So you put your first term in the top box, put your last term in the last box, and then you take what you got here from the table, so -1x, and oh, that's a positive 15x. And with this one, I don't know if you guys have seen this method or not, but you just work backwards. Like, what do these guys have in common? Well, they're both negative, so I'm taking -1 out. What do these guys have in common? Well, they have a 5 and an x. What do these guys have in common? Well, they both have an x. What do these guys have in common? Well, they both have a 3. So here's my factors, 5x minus 1 and x plus 3. So if you've used the box method in high school or some other way, it still works. Or if you use the x method, where you put your 5x up here, your -3 here, you're still putting a -1x and a 15x, and you're doing the same thing. So there's not when we were taught this, I knew nothing about the box method. I knew nothing about the X method. I knew nothing about the AC method. We just did trial and error like for days, it seems like, on a problem like this. I love having a method that tells me if this factors or not, because if none of these factors had added up to a 14, I would just put D and F. But because I found one group that did, I could break it apart and then use grouping on it. I like having a strategy that I know is going to work and not kind of running around the block for days and crying. So, okay, sorry, a little personal there. Any questions on these questions here on 17 and 18? All right, let's keep going. Let's see, I have 1, 2, 3, 4 slides, 5. Okay, so we have a few more left. So let's kind of pick up the pace a little tiny bit. All right, so we're solving now. We're not just factoring, but we actually have to solve the problem. It already is equal to 0. So that's our first step, right? Set equals 0. Second step is to factor. Whatever, pull out a GCF. Is it 4 terms? Is it, difference of 2 squares? Is it the sum of 2 squares? Is it an AC? Is it a trial and error? Whatever you need to do with your factoring. And then we're going to set our factors equal to 0. And then we're going to solve. So that's the process on every solve question. So first thing, it's already equals 0. So check, don't have to do that. I need to factor it. I only see 2 terms. So I don't need to worry about GCF. I mean, I don't need to worry about 4 terms, difference 2 squares and some of those, but I do always have to check for GCF. So it looks like they both have a 7 and they both have an X. So if I divide both of these by 7x, I'm left with an X plus 2. Okay, so step 1 is done, step 2 is done. Step 3 says set all your factors equal to 0. Step 4 says solve. So I just do whatever it takes to solve each of these. 0 divided by 7 is a 0. Bring the 2 over. And there's my 2 answers. It was an x squared, so I was assuming I could find 2 answers. If it were an x cubed, I'd be assuming I could find 3 answers potentially. All right, how are we with this one? This one was not the hardest one we've had to factor, was it? Okay, got a couple thumbs up, so I guess we'll go on. All right, so I'm only going to erase part of this. I'm going to keep those steps over there. All right, so this one says again, solve. So we know, let me erase our check marks because we haven't done that part on this one yet. All right, so we have to get it equal to 0. So we're going to bring that 49x over to join the x cubed. So step 1 is done. And now we get a factor. So I look at this, do you have a GCF? Well, yes, they both have some x's. It leaves me behind 2 and a 49. And then I look, okay, you don't have 4 terms, but you are a difference of 2 squares. So x minus 7, x plus 7 will give us the x squared and the 49. Okay, so step 2 didn't take me too long. Step 3 now says all my factors equal to 0. Step 4 says solve them. So this one's done. This one gives me a 7. This one gives me a negative 7. It was a cube, so I was looking for potentially 3 answers, and I found 3 unique answers. All right, any questions? All right, I don't know what the next one is, so let's see if I need to leave my writing or not. Oh, it's still a solve. All right, so what time is it? 5:05. Okay. I think I'm actually going to skip this one. If we come back, if we have time, I'll come back, but I want to make sure we get to all the other types. All right. So this one is an addition of fractions. We've done one something like this. Let's just do this one. It won't take us too long because there's not too much crazy factoring. So the first fraction doesn't have any factoring to do. Second one looks like I can pull out a 5. So now I can build my LCD, or my common denominator. First fraction needs an x plus y group. Second one says great, but I need a 5. So that's not too bad. The second fraction's already at the common denominator. The first one just needs us to multiply by 5. So multiplying top and bottom, so it's balanced. 35x on top, 5 times x plus y on bottom, plus, now this one has the same bottom, so I can go ahead and start joining. 2x minus 8. Add up the tops, I have 37x minus 8 for 5 times x plus y. 37 and 8 don't have any common terms, so I'm done. There's no canceling. I kind of feel kind of gypped on that one, but the common denominator wasn't too bad. This one, once we factor it, we saw that they already had something in common. The first one was just missing the 5. All right, any questions on this one? They don't have to be crazy, stupid hard. Some are not as hard as others. Some will take you a while. You've seen some, we had a lot of factoring to do, and it took me a minute or two. All right. Oh, this one's good. It's funny, I just talked about this morning with my class. I have a lovely 7 a.m. class, and they do a good job. All right, so again, we're going to do that keep, change, flip. So we have the first fraction divided by the bottom fraction. So we're going to keep the first fraction, change it to multiply, flip the bottom fraction. And now I'm going to look to see what I can cancel. I'm such a visual learner that I think I'm going to change the order. So I've got t times x on top. Let's bring that t squared and then move the x squared to the second term. It's multiplication, so we already talked about the way order doesn't matter. So t goes into itself one time and takes away one of these t's. X goes into itself one time and takes away one of these x's. So what are we left with? 1 times 1 on top, t times x on bottom. So that wasn't such a complex fraction. There wasn't much to it. There wasn't a lot of addition or subtraction. But once we did the keep, change, flip, it just reduced itself almost. All right, questions on this? They're not going to give you a crazy, stupid one on the test. It's going to be more simple. I love the keep, change, flip because it reminds me keep the top, change it to multiply from the division, and flip the bottom. All right, we're gonna throw something in the air. Is this the last? Okay, yeah. Okay, so I've been doing this a lot with my college algebra class too. We throw things in the air. As human beings, we like to throw things in the air. So this one starts off on the ground. It says from ground level. If you throw something in the air, what eventually happens to it? Does it stay up in the air? Does it keep going forever? Or does it come back down and hit the ground?
It falls down.
Yeah, unless you're like amazing and you send it into orbit or something, anything we do is going to reach a maximum height, right? This would be height. And at some point, it's going to come back and reach the ground. So let's see what they're asking us, because in my college algebra class, they're asking us how high, how long did it take to get to the top, which you guys won't do until you reach the very, very end of this class. But this one says, how many seconds does the object hit the ground? So what is the height if you're laying on the ground? How high are you? If you're laying on the ground?
Oh,
0.
0.
yeah.
So we want to know, when will this equation go to 0? That looks exactly like some of the others we've done, doesn't it? All right, so we're going to factor because it's already set equals 0. So remember our steps a while ago was get it equals 0, factor it, set your factors equals 0, and solve. Same steps. All right, so what do they have in common? Let's see, does 64 divide by 16? Oh, it sure does. So I'm going to take, it doesn't matter if I take a negative or a positive 16, so I'm going to take a negative out. And they both have some t's, so let's take a t out. So negative 16 divided by negative 16 cancels. There were 2 of the t's, I took 1 of them, so that leaves you with a t. 64 divided by negative 16 leaves me with a negative 4. There was 1 t and I took it to the front. So here's my factors. So step 2 is done. So now I just set my factors equal to 0 and I solve them. So this one I just need to divide by that negative 16. So t equals 0. And here I add 4. Okay, so now they got 2 answers. I need to see which one makes sense. So here's t equals 0. This one must be when t equals 4, because t equals 0 is when we started, right? That's not when I came back and hit the ground. I'm still at ground level at both of these points, but this is when I originally started. So I'm not going to give them this answer. I'm going to give them after it went up in the air, it came back and hit the ground at 4 seconds. So typically these give you 2 answers. One of them's not going to make any sense. One of them will be what you're looking for. Okay, I think that's a little bit of everything that you guys can expect to see. So do you have any particular questions or any that you want to go back and look at again? Or you think you're good? Keep in mind, you can still come in and get tutoring in the Learning Commons. We're here from 7:30 in the morning till 7:30 at night, except for on Fridays, we close at 5. So there's lots of resources here for you.
I'm gonna ask, I'm still in high school. I'm doing dual enrollment, but do I need to get an ID so I can go there and get tutoring? Or
Nope.
can I just go?